All right, guys. In this video, we're going to take those properties from our first video and apply them to problems, and we're going to be solving equations. This is different than anything we've done earlier this week. Earlier this week, I gave you expressions, things without an equal sign, and I had you simplify them, so we got them down as low as we can go. Starting today, we'll do equations, which have an equal sign, and we'll be solving for a variable. Our final answers for today should be something like x equals a number. For our first example, we'll be starting with a two-step equation. On these problems, I find it helpful to split the problem into two different sides, the left side and the right side. And the split happens right where that equal sign is. So I'm going to go ahead and draw a nice red line through the equal sign so that I can very clearly see this is the right side and this is the left side, so I won't get confused. Your goal on these problems is to try to get the variable by itself on one side of the equal sign. And so you need to move any numbers that are attached to the variable to the other side. When we're solving equations, we're going to do backwards PEMDAS. So what we would normally do at the end, we'll do at the beginning. So normally we do our adding and subtracting at the end of PEMDAS. When we're solving an equation, we'll do our adding and subtracting at the beginning. So the first thing that I'm going to do, I need to get rid of this plus 5 that is attached to my variable t. On our previous video, we learned that I'm allowed to subtract the same number from both sides of the equal sign, and I will still have a true statement. So I'm going to choose to subtract 5 from both sides of the equal sign. The reason why is that 5 and negative 5 are inverses, and they will cancel out. And it'll get rid of the 5 that was attached to my variable t. Now I still need to get rid of the 2 that is attached to the letter t. I need to move it to the other side. Since the 2 and the t are right next to each other, that means the 2 is being multiplied. We're going to use the inverse operation of multiplication, which is division. And on our previous video, we learned that it is mathematically sound to divide by the same number on both sides of our equal sign. So I'm going to divide both sides by 2. That allows me to cancel out the 2's that were next to the t. And now my t is all by itself, and so this should be my final answer. T equals 3. Okay, so again, your goal on these problems is to get your variable all by itself on one side of that red line that we drew down the middle. Now, when you're done with these problems, you do want to check your answers. I know that I normally tell you the answers when we come back to school, but maybe you just want to check and make sure beforehand. Or if we're taking a quiz or a test, it's really good to check your answers before you submit the answer to the question. So let's check and see if 3 is the correct answer. When you're checking your answer, you're going to substitute it back into the original problem. So I'm going to take this number 3 and I'm going to substitute it for the t in the original question. Next, I'll simplify each side of the equation down to a single number. If I did the problem correctly, I should get the same number on both sides. Since we're going back to simplifying, I will now use my order of operations, which says I should multiply first and I should add second. I got 11 equals 11. That's the reflexive property. That's a true statement. So I did a good job. And the final answer to this problem is, in fact, the number 3, like I thought it was. This is how you can check your work without asking me if you got the right answer. Let's do one more problem together, and then I think you'll be ready for your homework for the weekend. In this example, just like in the previous example, I will be drawing a red line through the equal sign, splitting this problem into a left side and a right side. This is important for when we use our properties. We want to make sure that whatever we do to one side, we do to the other side as well. We have to do the same thing on both sides. We don't want to accidentally do the same thing on the same side. That would not be good. In this problem, I noticed that we have some parentheses. If you see parentheses in a problem, you will be doing the distributive property. Since the distributive property only applies to the parentheses. You don't have to do it on both sides. You can just take care of it on the one side. So I will be distributing that 5 to the 2z and to the 9. Now remember, our main goal is to get the variable by itself. But that's a little hard in this problem because there's actually two variables. I've got two letter z's. Well, if I keep two letter z's, I don't know which one to get by itself. So the next thing that I like to do on these questions is I like to move my variables together. Since they're on opposite sides of the equation, since they're on two different sides of that red bar that we drew, I will need to use one of my properties to move one of them to the other side so that they're both together. I like to move the smaller one so that my answer will be a positive number. So if I have to choose between a 10z and a 7z, I'm going to choose to subtract the 7z so that the positive 7z and the negative 7z will cancel. And I do that once on the left and once on the right. The 7 and the negative 7 will cancel. And then over here, I'm going to get a positive number, which is just, it's really nice when the numbers are positive. So I'm going to do 10 minus 7, which is 3z. We will continue like we did on the previous example. I now have my letter z. I need to get it by itself, which means I will end up needing to move the 3 and the negative 45. I always will start by moving my adding and subtracting. Since it's already a negative 45 and I need to do the opposite or the inverse of that, I will be doing a positive 45 because negative 45 and positive 45 will cancel out. The final thing that I need to get rid of so that the letter z is by itself is that number 3. Since the 3 is right next to the z, that means it's being multiplied. And so the inverse operation, the opposite, would be to divide by 3. 3 divided by 3, this also cancels out, turns into an invisible 1. And I now think I have my final answer. Now remember, even though we think this is the answer, we should probably check it just to make sure. When you're checking, make sure that you're substituting back into the original question. If you're substituting into something that you created, you run the risk of checking something where you've already made a mistake. Maybe you accidentally did 9 times 5 and you got 40. Well, if you check it here, it's going to look like it's the right answer. So make sure that you're always checking back in the original problem, however complicated that may be. In this, now I have it's kind of like two expressions. I've got my left expression and my right expression. So I'm going to be using the order of operations on each side individually to simplify each side down to a single number. If I did the problem correctly, I should get the same number on both sides of the equal sign. So let's check and see if we can do that. Okay, on the left side, I'm starting by simplifying my parentheses. So I did 2 times negative 5, and I got a negative 10. On the right side, which is a completely different expression, the first thing that I'm supposed to do according to PEMDAS is the multiplication. Okay, so I multiplied 7 and negative 5. On the left side, I still need to deal with these parentheses. So the next thing I'll do is I'll figure out what negative 10 and negative 9 is. On the right side, I'm down to my last step, negative 35 and a minus 60. The final thing I need to do, and I'll probably break out my calculator for this, is make sure that 5 times 19 is actually negative 95, and it is. So again, we did a great job. We did find the correct answer. The correct answer is negative 5. On your homework for this weekend, please make sure that you're showing all of your work. If you are just writing down the problem and then instantly getting the answer, that's not good. I do need to see that step-by-step process. If you did the problem and you're not sure about your answer, you're looking at it and you're kind of like, this doesn't look right. I feel like it's not correct. Check your work. See if you did it correctly. And I'll see you all next week.